My dear student, Assalamu alaikum. This is Iftikhar Hussain again with a new topic in mechanics, that's inclined plane. Today, before starting, I want to make you people and see something. This is a strange object which has two surfaces. Now, if you see that the two surfaces are placed on one another, and you can move this one surface on the other. That's so strange. Now, if you see that thing, what I'm doing is I'm changing the angle of that surface, and the height is going to change. So from this apparatus, you come to know that we're going to talk about some inclined object, and that's inclined plane. That's what our topic is. Now, inclined surface means any surface which is making a certain angle theta with respect to the horizontal axis. Now, I can make the object stand on certain angles. For example, this is angle 35, this is 50, and this is 65. Now, as far as synboard is concerned, हम लोगों के यहाँ इस टॉपिक से एक क्वेश्चन लॉन्ग क्वेश्चंस में आता है जिसमें you derive a relationship for the objects moving down with certain velocity and an object which is stationary. Stationary, what do you mean by that? For example, if I have an object and it is at certain angle and I just move this object, this goes down. Now, if I just keep an object at a certain angle like this, it's stationary. Now, what are going to be the conditions for an object to be in stationary and an object to be in moving condition? Now, remember that surface of the inclined plane has a friction on it. So we are going to consider the forces. We are considering the object moving on a frictionless surface. That's going to be our main aim. So let's start with first a simulation and see what kind of forces are acting on an object when it's moving on an inclined surface. Okay, come on, let's use the software. My dear students, I have used a FET simulation to explain you about the objects moving on an inclined surface. सबसे पहला काम आपने जो inclined plane को understand करते हुए करना है, तो पहले आपने एक object को देखना है which is placed on an inclined surface. For example, we have an object which is placed on an inclined surface. Now, my first question from you people is, how many forces are acting on a block which is placed on an inclined plane surface? 2, 3, 4, I don't know. Let's see it. Now, if an object is placed on an inclined surface, there is a normal reaction force in a pink color which is moving upward, that is represented by R, and which is as per the Newton's third law of motion. The weight force is acting downward, which is represented by weight, and you see if the object is moving upward, if you are applying a force in the forward direction, then there is going to be a friction force which is going to be acting in the opposite direction, which is represented by the red line. इसका मतलब अगर हम देखें तो there are like three forces. Number 1, friction. Number 2, the weight force, and the third is the normal reaction. And you can see there are diagrammatic lines on that as well. Now in this software, what I can do is I can change the angle. I can just make it like 20, 30, and more. So you can change the angle and you can even change the position of the object. Oh wow, I can just slide down. That's nice. Alright. Now what I'm going to do is I'm going to apply more force on that. You have to see the direction of the lines first. Okay, where is going to be the weight, where is going to be the normal reaction, and where is going to be the friction force. Now if I change the angle, you can see the weight is going directly downward and the normal reaction is perpendicular to the surface, and friction is opposite to it. Now, and try to understand that when an object is at rest position, it means all the forces are going to be balanced. And if I change, let's see, I'm going to change the position over here, and the object is standing over here. Okay, now start with that. Now what we are going to do is we have to see the two conditions. Number 1, when an object is at rest condition and when an object is moving. The first condition is going to be the same as an object is in rest condition. It means normal reaction force is going to be balanced by some force. It means this force, the normal reaction is going to be balanced by some sort of force over here, and the friction is going to be balanced by some sort of force over here. So it means that we're going to talk about the resolution of forces. We are going to talk about how the weight is going to be resolved. कैसे weight resolve होके normal reaction force और friction force को balance कर रहे हैं. और अगर हम if we apply some force if you apply some force on it, like it's going to move, and smash. That's it. Let's start with some derivation and work on that as per requirement of the board. Now, my dear students, this is the vector representation of an object that is on an inclined surface. We have seen that how really an object moves on an inclined surface. Then we use a software. Now, in a software, you clearly observe an object which is placed on an inclined surface. Its weight is going to be perpendicularly downward. You can see from the diagram as well. This is mg. The force which is normally perpendicular to the surface is normal reaction. This is R from the surface, and this is the friction force, static friction force. Now, if an object is moving downward, what we are going to do is we are going to resolve the force, the weight. Now, you know that अपने previous classes में पढ़ा होगा कि we can resolve a vector into its two components. Number one, the horizontal component, and number two, the vertical component. Now, the horizontal component is basically the cos component, and the vertical component is the sine component. Now, if I resolve this vector weight, so we will get two components. Number one, this is perpendicular component, and this is the horizontal component. But this is theta. Opposite to theta, this is going to be mg sine theta, and this is going to be mg cos theta. In front of you, there are vectors, and you know that vectors can be justified, and they can be equal, they can be more than that, and they can be anything. When an object is in rest condition, what can be the possible conditions? In an equilibrium, you have talked about, अगर हमने equilibrium का topic पढ़ा होगा कि sum of all the forces are going to be zero. It means the forces can be along an x-axis and the forces can be along y-axis. So, the sum of all the forces along x-axis is going to be zero, and the y-axis is going to be zero. Now, z-axis, we don't have z-axis actually over here. Now, if we see, अगर हम यहाँ पे देखें along x-axis कौन-कौन सी force apply हो सकती हैं? Number one, mg sine theta, which is over here, as per parallelogram law. This is mg sine theta, and this is also mg sine theta, and this is friction force. Now, sum of all the horizontal forces should be equal to zero, and the sum of all the vertical forces should be equal to zero. This is the first condition for an object to be at rest. Okay, if this is the case, let's see which forces are going to be balanced by which force. Sum of horizontal force should be equal to zero. Now, in the horizontal axis, this is mg sine theta, and this is fs. It means they are going to be balanced. Yes, it is. Now, it means mg sine theta equals to f, and if I take it over here, mg sine theta minus f equals to 0. That's the first condition. And for the second condition, vertical forces should be equal to 0, which is r should be balanced by this component. And which is this component? Cos component. It means r equals to mg cos theta. If I take it over here, r minus mg cos theta equals to 0. So that is going to be the first condition. So, my dear students, this is the condition that I was talking about. An object which is at rest, which is not moving, it means all the forces are 0. Friction force, if it's going down, friction force is over here. This force is going to be balanced, which was mg sine theta. Normal reaction force from the surface is going to be balanced by its perpendicular component, that was mg cos theta. Now, let's talk about an object which is moving like this. So it means friction is less and mg sine theta is going to be higher. But what about the normal reaction force? That's always balanced. Why? Because it's not moving in a vertical direction. So let's see what is going to be the condition for an object moving, sliding down an inclined surface. Alright students, now the one of the important part that जो कि आपके exams में बार-बार पूछा जाता है कि what is the condition for an object sliding down the inclined surface. Now इसको you have to understand it, and you have to think how we are going to get a relationship for acceleration. पहली बात that you have to understand that how do you calculate the net force. किसी भी object में अगर आपने net force मालूम करनी है तो that is basically higher force minus the lesser force, you get the net force. For example, एक ऑब्जेक्ट पे एक डायरेक्शन में 60 न्यूटन फोर्स अप्लाई हो रही है और दूसरी डायरेक्शन में 100 न्यूटन फोर्स अप्लाई हो रही है, तो जो नेट फोर्स है दैट इज़ बेसिकली 40 न्यूटन फ्रॉम दिस साइड टू द अदर साइड. नाउ अगर हम ऑब्जेक्ट को देखें जो कि नीचे मूव कर रहा है, इसका मतलब एक कंपोनेंट ऑफ वेलोसिटी जो एक फोर्स है वो ज़्यादा है, विच इज़ mg sin थीटा, और स्टैटिक फ्रिक्शन का जो कंपोनेंट दैट इज़ वेरी लेस. इसी वजह से ऑब्जेक्ट इस इंक्लाइंड प्लेट पर स्लाइड डाउन कर रहा है. If you see the vertical component of the forces, वो balanced ही हैं, जो कि हम लोगों ने पहले condition में drive कर चुके हैं. So that's why summation F5 will always be equals to 0. It means normal reaction is going to be balanced by mg cos theta. That's our concept that's done along the y-axis. Let's talk about x-axis. Now if I ask you one question, अगर object नीचे जा रहा है तो mg sin theta is greater or fs is greater? Your answer, okay, correct answer. This mg sin theta is greater. Now, if you want to calculate the net force, same as I just told you before, that 60, 100 minus 60, so mg sin theta minus f is going to be the net force. And we all know that as far as Newton's second law, F equals to ma, that's ma. Mg sin theta minus f equals to ma. Now, if you want to calculate the acceleration of the object, this m is going to divide on both sides, mg sin theta over m and f over m. Now that's correct. Now one thing that you have to understand, that we always talk about ideal scenarios. Ideal scenario, again ideal condition. Yes, the ideal condition. It means we don't consider friction as to be a part of our motion. So what I did is I removed the friction force. That friction force is going to be 0, and the acceleration is equals to g sine theta. That's the final result for acceleration, which is a equals to g sine theta. It's always when an object is moving on an inclined surface, जब भी एक object inclined surface में move करेगा, उसकी acceleration का जो formula है वो a equals to g sin theta है. Downward a g sin theta, upward a equals to minus g sin theta. Now guys, इसके बाद there is a short question that always come in your exam. हमेशा 2 दफ़ा एग्जाम में आपसे पूछा गया है कि why all the object, जितने भी object हैं जो inclined plane पे होते हैं उनकी acceleration same क्यों होती है? अगर आप फॉर्मूले पे गौर करें, इफ़ यू सी ऑन द फॉर्मूला दैट a is g sin theta, acceleration depends on gravity and theta angle, and both are constant. So when both are constant, so every object, हर object, चाहे वो जिसका मास जो भी हो, जिसका मास 100 हो, 1000 हो, whatever the mass is, इनकी acceleration will be always same. Why? Because the formula said us the same thing. A is g sin theta, the value of gravity and theta. So that's why all the bodies which have whatever the mass they are going to have the same acceleration, and this is how you want to write the answer. So guys, I hope you have understood through the apparatus, through the software, through the presentation. I'm waiting for your comments. Thank you very much for watching my video.